Good afternoon, everyone. We're about to start our class today. First, just wanted to ask people if they can hear me all right. If you can, please just put like a thumbs up or something in the chat. All right, so where we're at this point is we are in our third unit where we're trying to discuss the difference between science and pseudoscience. And we're roughly halfway through, and doing this from home today, as maybe you can tell, because the weather out there is not very nice. So, yeah. So what we've been talking about up to this point is we were looking at some examples of science and pseudoscience and maybe some of the differences between them. And what I wanted to do was just finish up this little section with a little bit of a discussion about some more important points, I think, which distinguishes science from maybe other ways of learning and things like that. And one thing that I wanted to start out saying was sometimes we use language in science that has a slightly different meaning than what we might use in everyday language, everyday speech. And so I'm going to use the example here of the word theory and law, which are two terms that we use a lot in science, which have very specific meanings when we use them in science, which are different from the specific meanings that people sort of generally understand that these things mean. So as an example here, I have scientific theory. This is really what this is it's an explanation of some phenomenon that we can see. It explains why something happens the way it does. It sometimes will provide a mechanism, meaning sort of like what are the steps that happen to make a certain thing become true. They're always what we say provisional, meaning that they can always be elaborated on or possibly disproved, but you can never prove a scientific theory as being a certain thing. This is a bit different than the way we use the term theory in our everyday lives. An example might be of a theory would be, if you say walked into your house and there was a big puddle on the floor of milk in the kitchen, you might develop a theory about how that came to happen. And you might see, your cat walking around with milk on him or something like that. You might blame the cat or whatever it is. Basically, in that context, in our everyday world, we would use the word theory to really mean kind of a hunch that we might have, or a possible explanation for something. Where in science, we don't use the word theory. It doesn't say anything about how certain we are about it. We can be extremely certain, have a high degree of certainty about a scientific theory, and still it's going to be a theory. The other example I have is a scientific law, where, of course, in our everyday lives, a law is like a rule that you don't break. Where in science, what a law is, it's just a statement that describes some relationship, typically. Often, a scientific law is mathematical, not always, but it's not explaining why something happens or how something happens. It's just stating what that relationship is. So some people think, applying the everyday understanding of theory and law to a scientific theory and law, they might jump to the conclusion that a theory is sort of something that we scientifically don't understand very well, and a law is something that we're certain about. That's not true at all. They're two very different things. A theory never becomes a law. It's not like a law in training or anything like that. They're two different things, and they have different purposes. A law is a statement of a relationship. A theory is an explanation for why those things might be related the way they are. So here's an example of a scientific law. Ohm's Law. It can be stated as a very simple mathematical equation. Voltage equals current times resistance. V equals I times R. It just is a straight up statement of the relationship between these factors in an electrical circuit. It doesn't explain why these are related the way they are. It doesn't do anything beyond this single statement. An example of a theory is the theory of evolution. It explains why species change over time. If there was a law of evolution, the law might be, species will adapt and change over time to better survive or produce more offspring or whatever it is. But the theory is explaining how this happens or why this happens. It provides a mechanism, and this mechanism for evolution includes things like natural selection. It includes things like sexual selection. It includes all of the nuts and bolts of how genetic variation happens, mutations, all this sort of stuff is all part of the scientific theory. And the fact that it's a theory doesn't mean we're not confident in it or that we're not certain in it at all. So a good scientific theory it's consistent, of course, with all the knowledge that we have so far. We can verify it through observation and experiment. So, it's testable is another way to say that. It will predict certain things to be impossible. And if you have a theory which can't make predictions, then it's not really a scientific theory at all. And it must be refutable, and by refutable, this is in principle. It must make predictions that if the predictions don't come true, shows you that the scientific theory is incorrect. There can't be a change, you can't have these constant moving of the goalposts in a good scientific theory. So this is Ron Paul. He's a former American presidential candidate, and he says in 2007 that he doesn't believe in evolution because it is just a theory. And he should take my course because just a theory is not an argument against any scientific theory. And I think the issue with Ron Paul in this particular example is he's misunderstanding what is understood by the use of the term scientific theory. And he's not the only one. There's a whole website called justatheory.com where it's really sort of an anti-evolution website, which is basing, of course, its conclusions off of sort of from a religious standpoint, for sure. But because something is just a theory, that if you change the word theory here for explanation and say, I don't believe in the explanation of evolution, it's just an explanation, suddenly this doesn't really make sense at all. And that's really what we're saying when we use the word scientific theory. Gravity, just a theory. Doesn't mean it's not real, doesn't mean doesn't exist, or it doesn't mean that we're not confident that it's real and has impacts in our lives. Okay, so we do have a question here. Which of the following is not a feature of a good scientific theory? It is definite and does not change over time. It makes definite predictions. It is tested and potentially proved wrong or incomplete. It can be tested. And D, it is consistent with all current knowledge. So one thing about a scientific theory, which is definitely the case, is it can change over time. We're constantly testing scientific theories and finding areas where they need to be expanded or amended or, in rare cases, completely abandoned. And so theories definitely, as we learn more, do more experiments, gather more information, we do sort of amend scientific theories as we go. So the answer here is A. So another guy I'm going to pick on here, his name is David Avocado Wolf, and he is, to put it lightly, I would say not a believer in science, theories, or laws, generally speaking. He states that the idea that gravity is intrinsic to all matter, we're fighting gravity, we have to push our way through gravity to launch a craft up into outer space, all this is nonsense. So he is joining a growing list of online personalities like the Food Babe and Gwyneth Paltrow, and we talked about a few others who, for personal gain, let's say, puts a lot of information out there which is very strongly pseudoscientific. He actually has a method to do this which has become known as the David Avocado Wolf effect. And what you might find if you're on Facebook, you might find a lot of you in this class are, linked to his page or liked his page or fans of his page or something along those lines. And he has a method, we call this the David Avocado Wolf effect, of gaining followers. And so what he does is he makes memes, and he makes memes that are extremely shareable. So he makes memes that, you know, a lot of people appeal to a very broad audience, often very heartwarming. And this is just one example. Right after David Bowie passed away, this one came onto his Facebook page. The greatest thing you'll ever learn is just to love and be loved in return. And so, of course, you know, if you were a David Bowie fan or along those lines, you might click like for this particular one. You might subscribe. You might share it. All of these are sorts of things that he's counting on people doing and having his name spread that way. Here's another one. Love is when you sit beside someone doing nothing, yet you feel perfectly happy. Who can't agree with that, eh? Be who you are and say what you feel, because those who mind don't matter and those who matter don't mind. So countless ones of these, right? And the idea is by making these and having them spread and having them be shared, he's developing kind of an audience, he's developing followers, he's developing people who his more insidious messages can then be seen by. So here's another one. Mom, why isn't there a cure for cancer? Because, Jimmy, there is far more money to be made treating a disease for a lifetime rather than curing it in a day. So this might pop up to you as, you know, a bit of a red flag that we had talked about back in our first class, where we had these different flags for different things that we might see online that might make us suspicious. And this one is the conspiracy theory one. The idea here is there's a conspiracy theory, there's a conspiracy involving doctors, drug companies, the whole medical system, and other scientists, where the idea is we're trying to keep people sick in order to make a lot of money off their prolonged treatment over a long time, that if you just cure it, you actually can't make money off of this. And that if there is a cure, or maybe there is a cure, but it's being withheld because people don't want that money stream to stop. So this is a bit of an insidious conspiracy theory for sure. And, you know, this is just scraping the surface of some of the things that David Avocado Wolf is suggesting. He does, of course, like the other ones, have a store where you can buy all kinds of weird and wonderful things. Cosmic antler powder, all this stuff. He says things that like mushrooms are extraterrestrial organisms that have blown in to Earth, things like that. Anyway, one of the things he advertises and sells, he was one of the first people onto this particular craze, was selling these Himalayan salt lamps, which I have one upstairs. I should bring that down. Anyway, basically what this is just a lamp. There's a light source inside, and there's a big hunk of salt on the outside. And the light, of course, shines through the salt. And the salt itself has sort of got like a pinkish, orangish color to it. And it's mined near the Himalayas, in an area in Pakistan. I think it's still actually quite distant from the actual Himalayas. They don't actually come from the Himalayas themselves, but they call it Himalayan sea salt. And he's sold these on his website, and he's claiming they improve mental clarity, air quality, and sleep cycles. So the Himalayan salt, you know, you can buy it anywhere. It looks like this. It is just ordinary salt, sodium chloride, except it's, I guess you could use the word contaminated. It has trace amounts, maybe slightly more than trace amounts, of many, many other elements that are in there, which are providing that color, notably iron. But you know, 99% of it is just NaCl, so it's really not chemically very different from the salt that you would normally buy, just the white salt. It doesn't do everything from balancing pH to strengthening bones and lowering blood pressure, as it says up top. It does the exact same thing that any other salt will do. It doesn't have any special healing properties or anything along those lines. On his website, though, he claims that it neutralizes electromagnetic radiation, which is actually kind of funny because, you know, he's selling this as a lamp, and electromagnetic radiation is another word for light. And if it was true that it neutralized electromagnetic radiation, then wouldn't that mean light wouldn't be able to pass through it, and then it wouldn't work as a lamp? That's what it seems like to me, but what he's really selling this as is the idea that electronic devices like computers, phones, microwaves, you name it, are putting out harmful radiation, and that if you buy one of these lamps and set it near the device, this will counteract that effect somehow. There's no evidence for this, but a lot of people are kind of tricked into believing that this is a concern, this electromagnetic radiation, and will buy these, and not just buy one, but you'd buy one to put near every electronic device you own in the house. So maybe one by the TV, one by the microwave, one by wherever you use your phone, by your bed, by your lamps, all these sorts of things. The idea is to sell as many of these as possible, of course. It says at the end, they emit negative ions into the air to neutralize electromagnetic radiation. So that is 100% bullcrap. That does not happen. These do not emit anything into the air. It's just a hunk of salt. So yeah, this is his website, and you can see right at the very top, there's a shop where you can go and buy things. So this David Avocado Wolf effect, really, it's the idea that you put content out there that's very shareable, very user-friendly, in an effort to sort of gather up a bunch of followers. Once you have those followers, then you sort of insert your actual message, and if that message directs people to your shop, all the better. So what does the David Avocado Wolf effect refer to? Posting memes or articles with wide appeal in an attempt to gain followers so you can later promote pseudoscience or conspiracy theories. B, making a chemical sound bad for one application because it's used in some other dangerous or unappetizing application, which is more like the food babe effect. Spreading falsehoods about scientific facts, using articles to scare consumers into buying alternatives from your store. So yeah, A is the correct answer here. So one of the most important things that we can do as scientists, once we've gone out, we've done experiments, we've gathered information, we've come to conclusions, is to share that information somehow. And this is maybe changing a little bit, that maybe it's starting to become the case where information from scientists is starting to come out through Twitter and some other methods like this, but still, by and large, the most common method for the sharing of scientific information is through technical journals. And Science and Nature are probably the top two scientific journals that are out there. These are, of course, both online and in print. Some issues with these, first, is they're generally speaking written at an extremely high technical level, so they're not accessible to the average reader. Second of all, they're usually paywalled. So unless you have access through a university or something like that, or buy a subscription yourself, you can't get access to this information as well. So what ends up happening is there exist science journalists who try to translate results that end up in journals like this into scientific articles, which works with varying degrees of success. Sometimes you see things that are very skewed, and some things you see things that are quite well done. So yeah, the ultimate goal is to get published in ideally as high a journal as possible, so that your information is now available to the community, scientific community. Now I wanted to just bring up one story here. This photograph is one that I took myself. This is a picture that this is a display at which is museum in London, not the Royal British Museum, but the Natural History Museum in London. And this is actually a really interesting museum. It has a whole lot of the original samples that were taken by Darwin. It has all the fossil skeletons and so on of the early hominids and all this kind of stuff that I remember learning in biology when I was growing up. But I took this picture there a few years ago, and this picture is of a pair of birds, which are ivory-billed woodpeckers. And these birds were, they lived primarily in Florida and the kind of the lower U.S. states. They do not live in Canada, they do not live in Nova Scotia, although they look somewhat similar to a bird that lives here called the pileated woodpecker. Due to habitat loss and hunting and other reasons, they started to dwindle in number kind of in the late 1800s. By the 1920s, people had thought that they had gone extinct, when all of a sudden they discovered a pair still living in Florida. So they started to watch the populations a little more closely, although certainly at that point in time, people weren't overly concerned with conservation. In 1938, there was believed to be about 20 birds left in the wild. And all of them were alive that they knew about were in Louisiana. And in response to this, they went to their habitat and clear-cut it for lumber. And that, of course, wiped out whatever was thought to be remaining. And the last confirmed sighting of an ivory-billed woodpecker alive was in 1944. So the specimen that you see is in the picture is taxidermy, and I believe they were collected in, I don't know what the year was, like 1890 or 1895, sometime around then. So these are over 100 years old, these specimens. And yeah, so they've been extinct for a long, long time. So this is a picture of the ivory-billed woodpecker next to the pileated woodpecker, which actually lives in Nova Scotia, and they're quite large and pretty impressive birds if you ever get to see one. I'm just making double sure here, yeah. Checking my comments. So this is a side-by-side comparison. If you are a birder and you have sharp eyes, you can probably maybe see some of the differences between them here. Slight pattern changes or differences, coloring of the wings, but by and large, they're pretty similar, these birds. So in 2005, this article came out in the journal Science, which, as I said, is one of the top journals, as we understand it to be, in all of scientific publishing. It's usually the most important discoveries come out here, and they require a very high level of evidence, generally speaking. The article says, ivory-billed woodpecker persists in continental North America. And this is a bird that people have thought was extinct for about 60 years. No examples were ever seen, and they are claiming that they have found evidence that this is still alive in some area of Arkansas, in the Big Woods region of eastern Arkansas. They say visual encounters, video clip, and so on. And this actually was really caught up by the news because the media loves these kinds of stories when you have some animal that was gone extinct and then they find examples of that animal still alive somewhere. So this was good. And I was interested myself, not that I'm a huge birder or anything like that, but hey, I like birds. When you came in, maybe you saw some birds outside here, right? You can see this is my back deck where you can see there's a little, on the very corner of the deck, there's a feeder. It's all peanuts and mealworms all kind of crammed together. So the birds were going after that when I came in here. So I read the article, and this was the evidence that they had put forth in the article that the ivory-billed woodpecker was still alive. This was a still from a video clip that you can see up top, and they claim that was the ivory-billed woodpecker. It looks a little, pixelated and so on, not great clarity, but they're saying that's evidence that it's an ivory-billed woodpecker and not a pileated woodpecker, because they saw pileated woodpeckers too, and that's what they see down below in B. And if you compare A and B, I guess if you got a sharp eye, you could maybe conclude one is ivory-billed and one is pileated. I remember looking at that myself and thinking, like, I don't know, that's pretty poor evidence to me. It's certainly not convincing to me that the ivory-billed woodpecker is there and not the pileated. And when you think about it, what makes that better evidence than this? This is evidence of Bigfoot, right? You might be recognizing these pictures too. Why is this considered a conspiracy theory or pseudoscience, while this is considered science and is published in probably the top journal that exists? So that's a very interesting question. And why is that the case? And if that's the case, how can we trust, right, what we read coming out in scientific journals? And, I do have an answer for this. One, and this is unfortunate, I think. This is an unfortunate thing, is that if you look at this particular article, which is considered science, it has a whole bunch of authors, which for the most part are doctors. They have degrees, they have affiliations with universities, they have sort of the credibility and credentials to back up what's going on in this paper. And that really shouldn't be the case, right? A scientific study should stand on its own merits. It should be the evidence which gives credibility to the work. It shouldn't be the status of the person that is presenting that. One other difference, though, is that woodpecker is known to have existed with certainty at one point in time. We have samples like the one I showed you. So it's not out of the realm of possibility that it could still be alive, while there is no evidence that Bigfoot has existed or ever did, no direct evidence other than photographs like this. So that's another change. But the real thing which makes this bird paper science and the Bigfoot not science is the investigations that came after that paper was studied. Because of the intense interest in the reappearance or apparent reappearance of this bird, millions of dollars was actually spent to put ornithologists back into the woods to look for this bird, find more evidence that this bird might exist. I don't have a slide for that. To put evidence, to find that this bird actually does exist, and it went for years before they eventually came to the conclusion that, okay, maybe this bird isn't there. So basically what I mean to say is that every single article that gets published in science, you should not take as absolute truth. It's part of a long conversation, and there's many examples in science where one article gets published and then follow-up work has shown that the conclusions of that study were not supported or not correct. The author of the original study of this paper, one of the authors, I think it might have been the first guy actually, John Fitzpatrick, was asked after 5 years of millions of dollars being spent and thousands of hours being spent looking in the woods, he said, "I do believe that this bird no longer is in this region." He didn't come out as far as to say that it was probably never there in the first place, but that is probably the case, if you ask me. And I'm not an ornithologist, so maybe I'm wrong here too. Okay, so science, yeah, it doesn't always get it right, but I think the process of science is what I might describe as self-healing. That if there are things that get published that are incorrect, follow-up studies will hopefully root those out, lead to corrections or retractions or these sorts of things. And it also makes it hard, though, because it's hard to rely on a single study. Generally, what you'd need to do is follow the entire conversation, a whole string of studies, in order to come to a reliable conclusion. Media, of course, takes the stuff that ends up in these scientific journals and tries to present it to the public. And if the people presenting the information have an agenda, often that information gets twisted, or sometimes the opposite message from what the research originally showed is what comes out. So one way of misleading information, this is not an example of scientific information, but it's presenting the information in such a way is that a cursory glance would make it look like the take-home message is actually very different from what the actual message is. So this particular one is on Fox News, which is a well-known right-wing broadcaster in the United States, who by and large were opposed to any sort of democratic reforms, in particular Obamacare when that came out. And so there was a goal to get 7,066,000 people enrolled at a certain year by March 31st. 4 days before that, they only had 6 million. If you look at the graph, it almost looks like, only about a quarter, because they truncated the graph. They didn't start at zero. So it looks like, if they're trying to get to 7 million, they're like maybe a third of the way there or a quarter of the way there. Where if you look at the numbers, you can see that they're almost like, I don't know, 80% of the way there. So this is just one way of sort of misleading people, is showing information very quickly, flash it up on the screen, and present it in a way that makes it very difficult to get the true message from the information. You can see there's no scale on the left side. It's not obvious maybe right away that it doesn't start at 0. So yeah, this is just one example. Another thing which I think makes science for a lot of people very difficult to sometimes trust or difficult to swallow is that human beings by nature we are very intuitive. We tend to have a sort of a gut feeling about things and follow our gut feeling a lot. And we might trust our experience and our gut feeling over evidence, which might be more abstract. It might be difficult for us to comprehend or difficult to understand. And for that reason, a lot of people just don't want to trust the results of science. One thing that's very natural for human beings to do is confuse what I call, well, it's not me, what's called causation and correlation. So causation just means, event A happens and that causes event B to happen. Okay? It's like if you have a bucket of water, you turn it upside down, that's the cause. The result is water gets all over the floor. So that was a direct cause-effect relationship there. Correlation is when two things happen maybe in the same place at the same time. There's maybe no connection between those events, but because they happen to be related either in time or space, humans naturally assume there's a relationship between one and the other. And as a result, we've developed all kinds of superstitions, right? So we have a superstition about black cats, for example. There's a superstition that having a black cat cross your path is bad luck. You think about why that might be, there's probably no reason at all why having a black cat near you would cause any bad luck to happen to you if you believe in bad luck. But maybe at some point in time, some person fell into some misfortune after crossing a black cat, and for whatever reason in their own heads connected those two events. And from that point on, black cats were labeled. I have a cat, and if it's me, it was probably that they tripped over the cat in the dark, because black cats are hard to see. And my cat's name is Percy. I don't know where he is right now, but we often call him tripping hazard in our house because he likes to, get in your way. So I could see how a black cat could, in some cases, actually cause bad luck in that sense. So here's an example, confusing causation and correlation. There's a lot of things that are correlated that have no causative relationship with each other at all. So this is a graph showing fresh lemons imported to the US from Mexico in tons along the bottom. Total US highway fatality rates, and you can see that as more lemons are imported from the United States into the United States from Mexico, traffic fatalities are dropping. I mean, the truth is that fatality rates are just dropping over time for some other reason, maybe improved safety standards in cars, and fresh lemon imports are increasing as well, maybe because, I don't know, popularity of lemons, price, population, who knows. So these are two things that are changing with time, and they appear that they're related to each other, but they're actually not. It's just that they are correlated. There's no causative effect between these two things. Another very common example that's used in causation and correlation is looking at drowning deaths versus ice cream sales. And what's found is that as ice cream sales go up, drowning deaths also go up. Does that mean that consuming ice cream is going to increase your risk of drowning? Well, the actual relationship there is that as it gets hotter outside in the summer months, people have a higher tendency to buy ice cream. They also have a higher tendency to go swimming. And if they have a higher tendency to go swimming, they're more likely to drown. So there's actually no relationship at all between the ice cream and the drowning. It's just that they're both related, or they both have a causative relationship with a third variable, which is the heat outside, the temperature outside. Great, Jasmine. I'm glad to see that your psych profs are saying the same thing. We're all on the same page when it comes to this. Anyway, there's a funny website out there which I think is called Spurious Correlations, and you can go on there and you can see all kinds of kind of crazy things that appear to be correlated that have obviously no relationship with each other. Like the first one is number of people who died becoming tangled in their bed sheets versus total revenue generated by skiing facilities in the US, which yeah, definitely those aren't connected to each other at all. So yeah, be very careful about confusing causation and correlation. And I think we'll come back to this a couple of times throughout this course, that if two things appear connected, really think hard about why that might be the case. All right. So in this slide here, this is basically just a rough guide to spotting bad science. And these are some things that we often see with information that is presented online as science. If it's real science, it's probably being published in a scientific journal. Or if it's a media report, it's a media report on something that's published in a scientific journal. If it's not, or if it's bad science or pseudoscience, usually it's got one of these things going on. Either results that are misinterpreted, a small number of results, sensationalized headlines, not proper controls, all these kinds of problems. And I don't think I need to go through every possibility here. One issue, though, is that this isn't sort of a hard and fast rule necessarily. And that what I mean by that is there are journals that are highly recognized, that are highly respected, which are very reliable and great sources of information to be looking at. But there's other journals that look exactly like those other scientific journals that are not trustworthy at all. They're what we call predatory journals. And predatory journals are ones that will pay people to publish a paper in there. So if I write a paper and I want to get it published and I want it to have a journal number, all those sorts of things that scientific publications have, you can just go to one of these fake publishers and say, here's $5,000, publish my paper on your website, and do that. And so this happens for really two reasons. One is people want information out there that looks legitimate but really isn't, for whatever reason, and people will pay in those examples. Another one is there are some places where professors especially get promotions and they get tenure and stuff like that based on paper counts. And so if your paper count isn't really high enough, you might pay to have sort of extra, and I might call these fake papers, published in these types of journals as well. There's a lot of effort being put in to trying to track these particular journals and make it obvious for people to tell which ones are trustworthy and which ones aren't. But again, it's like one of these problems where if you identify one, and even if you can shut it down, because technically what they're doing is not illegal, two more will pop up in its place. So there's actually some very funny examples of these that people have found online. There was one of them, I think he wrote a paper and had it submitted where all it said was, take me off your mailing list. And it was like 5 pages of just take me off your mailing list, take me off your mailing list. And it kind of looked like a scientific paper. It had like little figures that just said, take me off your mailing list. But in the end, he submitted it to the journal with the money, and they ended up publishing it. Just because they'll publish anything. There's no sort of editorial process there. Whereas the more trustworthy, the more believable scientific journals will have an editorial staff who will go through and make sure that what's being presented there is actually valid. Okay, so this is really it for this particular unit that we wanted to talk about. It was more, I don't know, an attempt to try to at least make some important points about what distinguishes science from pseudoscience. Certainly, that's not something you can completely tackle in one unit, although I think maybe there's some nice examples that have come up. And I've tried to pick examples that are going to set the stage a bit for what's going to be coming forwards. You might be looking at this saying, like, you know, I signed up for a chemistry course. We're not doing any chemistry here. And yeah, there wasn't a whole lot of chemistry in this particular last unit. It's very much more general, but we will be getting back into something that's more recognizable and more specific as chemistry. We had a little bit more back when we did toxicity and that kind of stuff, but we'll be getting more back into the chemistry going forward. Now, my plan for today is just to leave that here. I don't think we need to try to jump onto the next topic right away. We went a little long last week, and I said I would make up for it this week, so we're only about, 45 minutes in. I think I'm going to stop the stream here, and we will resume on Wednesday. We'll start the next unit. Perfect. Thank you, everybody, and I hope you guys have a great day.